Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 9 is on the screen. Let's get started, please. Shouldn't take you more than about 6 minutes. Copy and go. All right, let's do this. Let's get the show on the road. Let's see. Let's go with our inequality, the green one. What you get for your green inequality, Julian? As x less than or equal to -3. Hands if you got that. That is correct. Pass someone. Gio, the red one. One is less than or equal to x. Hands if you got that. All right. And then we have the gap in between both, so we write what? Or. Then you close the bracket such that. Close the bracket. All right. Next. Pass on Gio for number 2. Jaime, tell me what to do to get started. What is it? F of x to y. We got y minus 5x plus 1. Continue. Subtract 1, subtract 1. That leaves us with y minus 1 equals -5x. Continue. Divide by -5. We're left with y minus 1 over -5 equals to x. Let me bring it over here. Y minus 1 over -5 equals to x. Pass someone. Carlos, what do I do at the end right there for the inverse? Swap the variables. So we end up with x minus 1 over -5 equals y. Technically, we are done. This is the inverse. However, we need to rewrite it in f of x form, the y, right? So then write this again. X minus 1 over -5 equals f of x. However, write the little -1 so that we know that that's the what? The inverse. That's what tells us that it's the inverse. Now, look up, guys, just to make sure we know what we're looking at. This is the inverse of what? Of this original one. Okay? All right. Check with the neighbor, see what they got for f of -1, f of 0, and f of 3. They should be done by now. F of -1, f of 0, and f of 3. Pass them on, Carlos. Who? Oh, Natalia Espino, f of -1, what'd you get? So f of -1 is since we're multiplying -5 times -1 is 5 plus 1 is 6. Hands if you got 6. All right. F of 0, pass them one. Natalia. Negative for this one? For f of 0? Okay, I'm sensing a disturbance in the force. So let's see. What is -5 times 0? 0 plus 1 is 1. And pass the last one to someone. Allison, what'd you get for f of 3? Negative 14 is correct. Whew. All right, copy the agenda, please. Warm-up number 8 done. Today we're finalizing the review on inequalities with compound inequalities. Tonight's home plate is 10 problems, play sheet 3.6b. All right. And copy the code for today's presentation, BG38E. BG38E. And you should have access to the play sheet in there in the Nearpod. However, I'm going to show you another route in a little bit as soon as you copy that code. All right. So, do me a favor on your Chromebooks. I want you to go to Canvas. Go to Canvas, please. Thank you. Canvas, go to Canvas. All right. In Canvas, you should see our course. Is that correct? Did it pop up? Should look something like this. Bam. Let's go. So, I included a button here for my YouTube channel, so you can click on that, and it sends you straight to the YouTube channel. However, this is where I want to go. Look up to the screen. Go over here to the left where it says Modules. Now, check this out. The first in there is the syllabus. The second is the assignment from last night, 8 problems solving equations and inequalities. So click on that, turning your home play there. And tonight's home play is this play sheet right here. You guys see it? All right, so that's where we're going to be turning in stuff and getting documents in case you don't get the code from Nearpod. All right? Yes. I'm sorry? I can't hear you. No, you're getting, the other ones are going to get created, but I need to make a report from Nearpod. All right, so send that in, please. I'll give you guys some time. Those of you that are on YouTube and following, if you are part of the class, you will be able to turn that in here. If not, just turn in or do practice on Nearpod. So last night's home play, it was only 8 problems, yes? Tonight looks something like this. All right. Really quick intro that I did with the scales for equations and inequalities. That brings us to the objective. All right, get a Cornell note, please. You don't need a Frere model. All right, here we go. So by now you wrote your objective at the bottom left of your notes, and once again, we don't need a Frere model. We don't need the big box at the top. So here it goes. It says, I can solve one variable equations and inequalities. Tell your neighbor what concept we've been working on so far. What concept have we been working on so far? Yeah, one variable equations and inequalities. What have we been doing? Solving them, yes? And yesterday we focused a lot on inequalities. So, we already filled our Frere model. We talked about the steps that we were going to take. Focus, please. Yesterday I said we need to simplify each side first. From there we need to isolate the variable, which means leaves it by itself. Did we plot the solution on the number line? Yes. And did we check our solution to graph our solution? Yes, right? We've been doing all that. Which brings us to today. Look up to the screen, writing utensils down. Once again, this is review. Focus, please. Hands off the keyboard. Look up to the screen. So let's say I give you this inequality. Can you get the lights, please? And I ask you to solve it. What do, everyone? -1 minus 1, yes? So that leaves us with -6 less than x. Let me graph that. 0. My dividing point is -6. I start with an open point since it doesn't have an equal sign. If I substitute 0 here, is -6 less than 0? Yes, so it goes and it shades everything to the right. So far so good, yes? All right, let me give you another one. To solve this one, what do, everyone? -1 to each side. These cancel. We're left with x less than 1. Let me graph that. My dividing point is 1. Open point. Check. Does it have an equal sign? No, it stays open. Let me check the 0. Is 0 less than 1? Yes, so I go towards the 0. Everybody there? Yes? All right. Today we're covering compound inequalities. Let's see if this makes sense to you guys. Compound, the word means to combine. What does that mean, Mr. Q? That means I can combine this inequality with this inequality. Look up. See what I did there? Therefore, this top one, before it's solved, is known as a compound inequality. We're going to be working with those today. You should have seen those in the past. So on your paper, here we go. Copy this one. Example number 1. Solve, graph, check, and write the solution set of -5 less than x plus 1 less than 2. And let's label example 1. Okay. All right. In case you forgot, do me a favor, writing utensils down. You'll finish copying in a little bit. Here goes. This one has 2 inequalities in one. So that means I need to draw my line down the inequality symbol and the other one as well. So question, can I simplify the left? No. The center? No. The right? No. To leave x by itself here, what do? To leave x by itself, what do? Inverse. So what is the inverse of +1? -1. We do that to all sides. So copy that, please. Do that to all sides. This cancels in the center. So on the left, we end up with -6 less than, bring down the x, less than 1. Are we done? Yes, because the x is by itself. All right. Next, let's graph it. Make your number line. Zero, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. All right, here we go. To graph this, look up to the screen. I'm going to start with the color green, and I'm going to box the left side dividing point with that x. So what is my dividing point, everyone? My dividing point is -6. So we start with an open point. Next, what number would you like to check to where we're going to be shading? Julian. -1. Okay, let's check -1. Substitute that in here for x. Bring down the rest. And let's read it. Is -6 less than -1? Yes, that's true, which means we're going to shade towards -1. Make sure you go all the way through. Next, I'm going to switch colors. If you have red, I'm going to use the X again, but now I'm going to go with the other dividing point. So, what's my dividing point here? My dividing point is 1. So, open point on 1. Does it have an equal sign? No, so it stays open. So, what number would you like to check this time? Julian. -1 again, okay. So we're going to substitute -1, bring down the less than, bring down the 1. Okay. So, is -1 less than +1? Yes, so that means we're going to shade towards the -1 and keep going. All right. So, what do you guys notice on this kind of graph compared to the one on the warm-up? The two graphs intersect, is that correct? I want you to label this AND. This is what we call the AND compound inequalities. And last but not least, it says write your solution set. So, the set of x such that, what was our final solution, guys? This right here, look up. This right here was our final solution. So we would write -6 less than x less than 1. So what does that mean? Let's double check. Look up to the screen. What does that mean? That means that our solution has to be between what two numbers, guys? -6 and 1. So that means the solutions are from here to there, right? Solutions. However, since we have open points here and here, does it include those numbers? No. Anything in between except -6 and 1. So what does that mean over here, Mr. Q, where the green is at? Look up. Over here, that's no solutions. And how about over here, Mr. Q? That's no solutions. The only possible solutions are in between here. Is it coming back? Yeah, for some of us? Yes, Mr. Q. All right, let me send you the screen so you can send me your notes. Give me a second. All right, example 2. Copy this one. You don't have to copy the instructions anymore. Compound inequality is -9 less than x minus 10 less than -5. Do that one by yourself. You should be able to do that one by yourself. It's just like the one we just finished. Copy and go. Give you a head start. All right, check in with your neighbors, see where they're at, and then Scarlett's going to get us started with this one. All right, so this is the compound inequality. So I'm going to do a line down the first inequality and the second inequality. So what is our first step, Scarlett? Add 10 to all sides. Hands if you got that. That is correct. So we're left with, let's see, 1 less than x less than 5. Hands if you got that. All right, let's graph that. All right, so we got 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, I'm going to start with red on this side. Pass on one, Scarlett, so it can help me graph. What do I do? Open circle on what? On positive 1. Does it stay open? Yeah, because there's no equal sign. Okay. Which number would you like to check, Julian? Negative 1 again. Okay. All right. So negative 1 for x. Bring down the 1 and the less than. Let's read it. Is 1 less than negative 1? No, that's false. So we're not going to shade that way. We're going to shade the opposite direction. Oh, let me see. All right. Continuing, I'm going to switch to green for the other portion. What do I do? Open circle on 5, and it stays open, right? All right, and what number would you like to test, Julian? Negative 1, okay. Keeping us constant, so here is negative 1 instead of x. Bring down the less than 5. Let's read it. Is negative 1 less than 5? Yeah, so we're going to shade towards negative 1. Look. That way. Okay. Do both graphs intersect? And we're going to write what above it? And once again, and that tells us that our solutions is in between what numbers? 1 and 5. Those are our solutions. Does it include 1 and 5, people? Let me repeat that again. Does it include 1 and 5? No, why not? Tell your neighbor, why doesn't it include 1 and 5? Then Leo is going to enlighten us. Why doesn't it include 1 and 5? All right, Leo, since you were like really conversing with your neighbors over there, why doesn't it include 1 and 5? Because the points are open. If they're open, that means it doesn't include the 1 and it doesn't include the 5. That is correct. And because this inequality right here and this one do not have an equal sign. All right? Solution set of x such that, and our solution is 1 less than x less than 5. From 1 to 5, how comfortable are you with these? 5 fours, 5 fours. Okay, let me send you a screen of 3. All right? Let me send you a screen so you can send me your notes, please. Copy example number 3. Example number 3. Solve graph, check, and write the solution set of 8 less than 3x minus 1 less than or equal to 11. All right, let's do that one together. Here we go. Line down the inequality symbol. Line down the inequality symbol. All right. Let's see, who helped me out? Was it Leo? Leo. Okay. So now that we're getting started here, can we do anything on the left? How about in the center? Can we simplify that? Nope. How about the right? No. So now we need to start by leaving x by itself. Circle that. So what do I do there, Leo? Add 1 to all sides. Very good. This cancels. We're left with 9 less than 3x less than 12. Bless you. Is the x by itself, everyone? No. What do, Leo? Divide by 3 to all sides. So that leaves us with 3 less than x less than 4. What's that? Oh, this one's equal to, sorry. Forgot. Thank you, Gloria. There it is. All right. How are we doing so far? All right, let's graph this. Let's get our number line. There it is. I'm going to put the 0 somewhere right here. Got 1, 2, 3, 4, 5, 6, -1, -2. All right. Let's go with the left side. Pass someone, Leo. Carlos, tell me how to graph that. Open circle on 3. First, we're finishing off the red first. All right, and then what number would you like to test out? +2? Okay. So we substitute 2 in here. Bring down the 3 less than. Is 3 less than 2, guys? Is 3 less than 2? No, that's false. So that means we're going to shade not towards 2, but the opposite direction. All right, pass on one, Carlos. Miguel, do this next section in green. What do I do? Close point on number 4. Why closed? Because it's got an equal sign. Yes, that is correct. What number would you like to test or check? 3? 2? Okay. So I'm going to do 2 for x. Bring down the less than or equal to 4. Is 2 less than 4, guys? Yes. So that means we're going towards 2. There you go. And this is a what? An and. And the solutions are between what? 3 and 4. So which one is not included? Three. And everything in between all the way to 4, yes. Okay, so our solution set of x such that 3 less than x less than or equal to 4, close bracket. From 1 to 5, I'll come to argue with this so far. Yeah? 3, 4, 5, 4, 5. Okay? Send me your notes, please. Copy this next one. Example number 5. Example 5. What's that? We're on 3? Okay, copy number 5. Yeah, I skipped 4, Carlos. Thank you for pointing that out. Appreciate it. All right. 8 plus t greater than or equal to 7, or 8 plus t less than 2. Copy that. All right. Here we go. I'm going to start with this one right here. You're like, why? What do you mean start with that one? Well, isn't there the word or between those two? Yes. So I'm going to start on the left side with red. Line down the inequality symbol. What do I do to leave t by itself? Tell your neighbor, what do I do to leave t by itself? Minus 8 minus 8, that leaves us with t greater than or equal to -1. Tell your neighbor why I didn't flip the symbol. Why didn't I flip the symbol? What? It's cold? I didn't even notice. There you go. Yeah. All right, why didn't I flip the symbol? Who went last? Carlos? Was it Carlos? Oh, go ahead, Miguel. Pass them one. Why didn't we flip the symbol? You didn't divide or multiply by a negative. Okay. Let's continue. Or. Let's do the second part in green. Line down the inequality symbol. What do we do to leave t by itself, everyone? Minus 8 minus 8. T is less than negative 6. Question. Look up. This is the solution. Tell your neighbor what you predict the graph will look like for these inequalities. What is the graph going to look like for those inequalities? All right. Prediction. What was the prediction? Who went last? Julian? Pass someone? Allison, what do you predict on that on this graph? How are the graphs for the red and the green going? How's the graph going to look for this solution? They're not going to intersect. Oh, let's see if it's true. 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, 1, 2. Okay, so let's start graphing this one. Our dividing point is negative 1. I start with an open point, but since it has an equal sign, what do? Fill it. Which number would you like to test, Julian? Yeah, we already have negative 1. Positive 1, okay. So let's test positive 1. So 1, is 1 greater than or equal to negative 1, guys? Yes, that's true. So we're going to go towards 1. Let's graph this one. T is less than negative 6, so open point. It stays open because there's no equal sign. And what number do we test, Julian? Back to negative 1, okay. All right, so we're testing negative 1, this one right here. So less than negative 6. Is negative 1 less than negative 6? No, that's false. So instead of going towards negative 1, we go the opposite direction, which is in that direction. And Allison predicted that they did not intersect. Allison in the house. Let's go. Empty space here, so this is a what? Or. So, write your solution set of T, such that, close your solution set, and what do we write in here? Look up, we write all this. T is greater than or equal to negative 1, or T is less than negative 6. All right, how we doing? Good, Mr. Q. All right, send me your work, please. Give me a second. Example 9. It said, the question was, do the two graphs intersect? Yes, they're intersecting here, so that means the solution is in between what values? -2, and 5. So that means this represents what? Which is x. Is that correct? All right. And anytime that you write a and inequality, you do less than, unless there's a solid point for each of these, you write the equal sign. Now, are we done? No. We need our bracket set notation, solution set of x such that, close notation. All right, let's do one more. We still have time. Copy this one. Example number 10. What do you guys notice in the middle? It's an OR. Okay? So what's the dividing point for this one? -3. All this is x. And what are all these numbers compared to -3? Less than, and it's a solid point. This one is 2. All these are x. What is 2 compared to all these? Less than or equal to. And we write solution set of x such that, and we close it. And we'll stop right there. Those of you following on YouTube, make sure you go get your practice in. See you guys next time. Peace.